In data communication and networking, we'll talk about cryptography today. Cryptography. So, first, we'll try to introduce the common terms which are used in cryptography, and we'll give some taxonomies also. So, cryptography components are like this. If this is the sender and this is the receiver, a sender and receiver, a sender sends a plain text. Then, after encryption, encryption is in layman terms, it is encrypting something, or in very basic level discussion, encryption means in certain way hiding your content, hiding your data, or making your data not available to anyone else rather than only to the person who is supposed to get it and to decrypt it or to understand it. So first, plain text is sent by the sender, and after encryption, this plain text is now known as a ciphertext or ciphertext. Then decryption is applied on this ciphertext, and the plain text is retrieved from the ciphertext, and the receiver receives it. So in cryptography, there are two type of keys which we use to encrypt the data or the content. The first is your symmetric key. Here we use a secret key. In symmetric key, we use a secret key, and in asymmetric key, we use a public key. In symmetric key cryptography, the first one, this is the plain text. You have encrypted it. This becomes the ciphertext. Now, decryption and encryption, there will be a shared secret key for encryption and decryption. There will be a shared secret key to encrypt and decrypt. This is the symmetric key cryptography. So in symmetric key cryptography, the same key is used by the sender for encryption, and the same similar key is used by the receiver for decryption, and this key is shared between the sender also and the receiver also to encrypt and decrypt. Now this is the example of asymmetric key. What happens in asymmetric key? Encryption is done, decryption is done. Say if Alice is the sender, Bob is the receiver. Bob has a private key. Bob has a private key to decrypt it, whatever has come as a ciphertext. And the Bob's public key is used for encryption, and this is also for the public to encrypt it. So encryption can be done by using the Bob's public key, while the decryption can only be done by Bob's private key. The key which are used in cryptography, in symmetric key, the secret key is shared by Bob and Alice, while in asymmetric key cryptography, there is a public key which is available to everyone, but the private key is only available to the receiver because he or she is going to decrypt using the private key. So what are the comparison? How can we compare between these two categories of cryptography? In symmetric and asymmetric, in first case, the encryption or locking of your data or content is done by a certain key. This same key is used for unlocking your data or the content. And in the asymmetric key, you lock it using the public key. So public key can be used to lock or to encrypt, but the decryption is only possible with a private key, only private key. We'll see the advantages, disadvantages, etc. also. First, we'll talk about the symmetric key cryptography. In symmetric key cryptography, it started thousands of years ago when people needed to exchange secrets. More often in wars, because you don't want your data or content to be seen by any of the enemy. We still mainly use this symmetric key cryptography in the network security. We'll see about all these traditional ciphers, simple modern ciphers, modern round ciphers, and mode of operation. These are the traditional ciphers. These traditional ciphers, you can divide them into simple substitution ciphers, which can be monoalphabetic, means you substitute certain character with another character. Only one character is changed. While you can have various characters to be replaced. So traditional ciphers, in the substitution, you just do the substitution. Means if A, B, C, D is there, and A, X, this is the data. You replace A with say Z. So this will become Z, B, C, D, Z, X. While transposition ciphers are something different. We transpose with certain technique. These are the traditional ciphers. A substitution cipher replaces one symbol with another, as I just showed you. Let us take an example. This plain text is hello. It shows the plain text, and you have a cipher text also, which has been done using certain say encryption, and we are trying to answer with respect to the traditional ciphers, that is substitutional ciphers. And as we see that E L H E L L O has become K H O O R. How or in what way you can understand it to be either monoalphabetic or polyalphabetic? The answer is the cipher is probably monoalphabetic, because both the occurrences of L, they are encrypted as O only. Okay, so say H is replaced by K, H will be replaced by K, and E by H, and L by O, and O by R. This is substitution of single alphabet only, so that is why we understand it to be a monoalphabetic cipher. In this case, we also have again plain text and a cipher text. How can you tell that the cipher or the substitution is monoalphabetic or it is polyalphabetic? We can easily find out that two L's, which you can see here. One L is replaced by N and the other is replaced by Z, that is Z. So this is not monoalphabetic, because each occurrence of L is encrypted by a different character. The first L by N and the later by Z. The shift cipher is sometimes referred to as Caesar cipher also. Shift cipher means you replace A by, say I have A, B, C, D and so on till Z. So I shift means I replace A by B, I replace B by C, C by D. So this is one shift. So there can be number of shifting which can be used, and this is known as the Caesar cipher. Let us use the shift cipher with key 15 to encrypt the message hello. How we are going to do it? To encrypt each character at a time, each character is shifted 15 character down from A to Z. You have to see where this H lies. Let us start with H. And after 15 shifting, 15 number of shifting, what character we get? So H will be replaced by Z, because H is replaced by W. W comes 15 alphabets after H. Likewise, E will be encrypted with T and L by A. And the second L will be, because again there will be shifting of 15, it will be A, and O is encrypted by D. So we get the cipher text as WTAAD. How we can use this shift cipher with key 15 to decrypt the WTAAD? And the situation is just reversed. So we will decrypt one letter at a time. Each character is shifted 15 characters, because earlier we shifted down. Here we shift up, and W will be shifted up, that is after 15 characters we'll get H. So it will be H, and likewise for others. So by shifting upwards 15 characters, 15 alphabets, you'll get it as hello. So a transposition cipher, it reorders or permutes. Certain permutation is done. A transposition cipher reorders symbols in a block of symbols. So this is the transposition cipher. If you have a plain text, say a block, we reorder it in say downward direction, and the encryption is done using this transposition cipher. And the cipher text can be decrypted using reordering in the upward direction if it has been done while encrypting in a downward direction. What is the key? Say 1 is shifted or reordered or transposed by 3, 3 by 4, 4 by 2. Okay. In the similar fashion, with decryption will transpose or will replace 4 by 3, 3 by 1, like this. Let us encrypt the message hello my dear using the key we just saw in the earlier figure, that is this transposition cipher. So we'll first remove these spaces, these are the white spaces, we'll remove it. We then divide the text into blocks of 4 characters, and like HELL, we add a bogus character Z at the end of the third block. Why? Because if we combine this in 4, it will be O my D and EAR. So what about the fourth one? So we'll add Z. So the result will be like this, EARZ. So we create a 3-block ciphertext, that is ELHLMDOYAZER using the previous one. Okay. How we get E? The E has got its value because the encryption in the downward direction is second by 1 by second. So let me tell you one or two of these. H, let us take H. The first one, H, the first, because we are going to the downward direction, so first will be replaced by second. What is the first? Second one is there, E. So we will replace H by E, the second one. In this similar fashion, let us take E. So we see that in this, the third will be replaced by first. Third will be replaced by first. So what it will be? Third will be replaced by the first. So L will be replaced by the L only. Okay. So in this case, we can create a 3-block ciphertext like this just by taking the advantage of 1 with 2, second with 4, 3 with 1, likewise. See, 3 with 1 is L is replaced by H here, 3 by 1. Now the next question arises, how to decrypt the message. So we have ELHLMDOY, what we have made, and the result will be something like this. How? We'll remove the bogus character, like because we have HELL, OMID, ERZ. This is what we have. EHLM, this is what we have received. So once we have received this one, actually the result was this only, which we got from here, and the ciphertext is like this. Now we want to decrypt this message. So the result will be like this. How? Because after removing the bogus character and combining the characters, we'll get hello my dear. How? If I take ELHL MDOYAZER and I follow the technique which we used in the decryption direction, that means whatever the first position will replace by the second one. So what is the second position? What is in the second position? So second position, we know that it is this one. We start with the 0. So it will be H. Okay. In the similar fashion, we see that 4 will be 3. So what is 4? 4 will be 3. So it will be 1, 2, 3, 4. L will be L only. 4 will be 3 only. This L. 4 will be 3. So this is by taking the reverse direction, we can easily find the actual data. We can decrypt the message which is used here. So you know there is nothing going on here. Just we are using the positional values. We are not doing any other thing here. And we have XOR cipher also. The input is XOR and then the output is received. The rotation cipher is the input is rotated. Rotated means this comes here, this comes here. This is kind of rotation, and the first goes to the last one. S box is also there. S box, a function that matches n inputs to m outputs. So you have n inputs and we only have m output bits, and we'll see that when we uncover or when we decrypt, we use the reverse direction. This is p boxes, straight p boxes. This is expansion, means one can have 2 values, 2 can have 1 value, 3 can have 2 values. Compression also means you can compress it. We will not use 1 and this one. We'll just use 3 of these to find out 1, 2, 3. And this is the straight one, 1, 2, 4, 5 to 1, as we have seen in the previous. Now we come to DES. DES, this is a 64-bit plain text. We do certain initial permutation, and the various keys, which is our 64-bit key, and this is a round key generator. Various keys are applied first, then this is done 16 times. These keys are applied 16 times. Means first time key is applied, some ciphertext has come. Then we reapply it with certain other key. So 16 keys are applied 16 times, and then the final permutation is received, and we call it as a 64-bit ciphertext. This is the DE. This is also an encryption scheme. So this is the one round in your DES, data encryption standard, DES cipher. So this 64-bit, the left one and right one is applied with the KI, that is the key which we have of 48 bits, and now the resultant 32 bits after applying the key is XORed with the 32 bits, and then we have right is replaced to the left bit which is XORed with the this result will be placed at the right bit. This is the first round. And what about the decryption? Decryption, in this decryption, the left bit will be given to right bit, while the right one will be XORed, and then the bits which has been applied, so this will go after XORing to left one, and this will go to the right one. This is how we do the decryption round. This is DES function, as we have just seen. This is triple DES, triple data encryption standard. How we use this triple DES? First, we encrypt using DS. We apply key to decrypt DS. Then we again encrypt DS. Then we get the 64-bit ciphertext. And the decryption, of course, in the manner in which we have received this, again in the reverse manner. What about AES, that is Advanced Encryption Standard? This algorithm AES was developed by two Belgian cryptographers, Demon and Rijman. So AES was designed to be efficient in both hardware and software. It supports a block of length of 128 bits, say a key length of 128, 192 and 256 bits. As you can see here, this is the size of data block, 128 bits. These are the number of rounds, and key size are like this. So AES has three different configurations with respect to the number of rounds and key size, as we have just seen. In this AES, what we do here is we have a 128-bit plain text. These are the 128-bit key, and this is the round key generator. So first is applied here, and then we get the first phase. We applied it to the K1, say 1 to 10 round, and then we get the, with all the keys, and then we get the 128-bit ciphertext. The structure of each round, as we have seen in the previous figure, is 128-bit data is done, or substitution is done byte-wise, byte substitution. Then you do some shifting, that is byte permutation. Then mixing of columns. It is a complex operation mixing, which you don't find in round 10. Otherwise, in 12 and 14 you will find. Then you add a round key with this key, and then you get this 128-bit data. See, the modes of operation for block ciphers are ECB, CBC, CFB, and OFB. These are different operation mode. First, we'll see the ECB. What are the operation modes of this? So before we go ahead, let me tell you something about this operation mode. In cryptography, what happens? A mode of operation, it is an algorithm that uses a block cipher to produce an information service, such as, say, confidentiality and authenticity. So a block cipher by itself is only suitable for the secure cryptographic transformation, that is encryption or decryption of one fixed length group of bits called a block. So what is this ECB and this CBC, CFB and OFB? This is ECB is electronic code block mode, and this CBC is a cipher block chaining mode, and this CBC, as you see here, this is cipher feedback mode, and of course the last one, that is the OFB, is the output feedback mode. In this we have n bits, and the encryption algorithm is applied. So this n bits, the plain text block is PI. The cipher text block is CI, PI and CI. So see this PI bits into CI, that is cipher blocks, and then this is applied. So this is ECB. While in CBC, we have n bits, and you also have certain CI minus 1 n bits, and these are combined. These are initiated with some initialization vector, and these n bits are encrypted. So PI is your plain text, CI, this one is your cipher text, and IB is the initialization vector, and then you decrypt it using the CI1 used here. While in CFB mode, we have this n bit shift register, initially initialization vector. Then CI minus 1, that is R bits, are used to encrypt, and then you have this apply this actual key with some R bits, and these R bits are sent. R bits are then again applied with the actual CI minus 1 which you used here, and then the encryption is done along with this. So there are two modes. This is what it is going on. So you apply it here with n byte shifting register. So this is again shifting. So you again apply this R byte CI minus 1, and this CI minus 1 is applied here. Then the actual key is combined with these R bits. So this is CFB mode. And what about OFB mode? OFB mode, we have this n bits with some initialization vector, the encryption algorithm with n bits, and now this R bits is this after applying this. This is applied to the n bits. In the actual key combined with the R bits, you will find this CI. And in this case, again, you have this n bits, because this is again an initialization vector with n shift register. This is n bit shift register. So when n bits are received, you apply this key for encryption algorithm, the n bits. Then whatever R has come, the R bits are applied again here, the actual key, and these two, they are combined, or XORs you can say. You get the PI. So this is the symmetric aspect we have seen. In the next session, we'll take the asymmetric one. Thank you so much.